In this video, we discuss learning outcome number 5 from lesson 6.1. Here we're asked to find z-scores associated with known areas or probabilities. We also want to relate percentiles in areas and define critical values and find critical values. Now, in the last video, we talked about finding areas and probabilities when we were given z-scores on the boundaries of those areas, which were associated with probabilities. Now we're doing this backwards. Someone's telling you the area and they're asking you to find a corresponding z-score or a corresponding range of z-scores. In order to solve these problems, I highly recommend you draw a picture. I would start by drawing a bell-shaped curve and then identifying the region under the curve that corresponds to the given probability. This might be an area to the left or an area to the right. If it's not an area to the left, I would find that corresponding area to the left. So if they give you an area to the right, just take the complement. 1 minus the area to the right would be the area to the left. And then once you've got that picture, you can use technology. I'll show you how to use Excel, how to do this, or you can use table A2 to find the corresponding z-score. You won't have access to Excel during your exams, but you can always use A2 table A2 during the exams. So I would get comfortable with both and practice using A2 so that you can prepare for your exams, but then maybe check your answer using technology. If you are using table A2, this time we're trying to find z-scores that correspond to areas. So first you would find that area to the left of the z-score that you're interested in. And then once you know what that area is, you're looking for that area in the body of the table this time. Before, we were looking at the z-scores on the outside and finding the area in the body. Now we're doing the opposite. We're going to the body of the table, finding the area, and then finding the corresponding z-score if we're using table A2. In Excel, we're just going to use a function. It says it's called NORM SINV. So that's the standard normal function, but we're taking the inverse of that. You'll actually just type in that function name, and then in parentheses, you'll type in the area to the left, and that'll give you the z-score. The Excel program will return the z-score to you. It's actually really nice and very convenient. So let's look at some bone density test results. This is the same problem statement, or at least the beginning of this is the same problem statement that we saw in the last video. It says a bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis. The result of a bone density test is commonly measured as a z-score. The population of z-scores is normally distributed with a mean of 0 and a standard deviation of 1. So these test results meet the requirements of a standard normal distribution. Now, first we're asked to find P sub 80. Remember, that's the 80th percentile. That's the bone density result separating that bottom 80% of bone density test scores from the top 20% of bone density test scores. Now remember, those percentiles actually correspond to areas under the curve. So the first thing that I would do is I would draw this normal distribution, and then I would draw a line segment over here, and I'm trying to draw it in such a way that 80% of the area is to the left and 20% of the area is to the right. Now, if I'm drawing this on a piece of paper, it's really anyone's guess where that 80% line is. But you know 50% is on that middle line. So if you're talking about 80%, it has to be to the right of that middle line. And then you're just using this sketch to help you to conceptualize what's going on. It doesn't have to be perfect. And then you want to find, you know that the area over here is 0.8000. So that area is 0.8. Now we want to go to our table A2 and look for 0.8 in the body of the table, and we want to find the corresponding z-score. So let's do that. Now, since 0.8 is greater than 0.5, we know that the z-score has to be positive. And so I'm in my positive z-scores table, and I'm looking for 0.8. Now, you're probably not going to have exactly 0.8 in the table, but you're going to try to get as close as you can. Okay, so I've got 0.7939, 0.7967, 0.7995, and 0.8023. Now this number is 0.0023 from 0.8, and this number is 0.0005 from 0.8. So this is the closest number. So I'll circle that. And what we want is the z-score that goes with that area. So it looks like the 10 or the ones place and the tenths place is 0.8. So we have 0.8. And then if I go to the top here, oops, that's not what I wanted. Then we see at the top that the corresponding tenth or hundredths place is 0.4. Oops, I guess that moved a lot. We were down here. Sorry, let me clear that. Let's do that again. So we're looking for the closest number to 0.80, because we're looking for the 80th percentile. And the closest number that we have in the table is this one. That one right there. And you want the z-score that goes with that. So there is the beginning of that z-score, it's 0.8, and then in the hundredths place, we've got a 4. So 0.84 is the z-score that is closest to that 0.80 being the area to the left. Now you can see that it's not exact. The actual z-score is going to be a little bit more than that in order for us to close that gap on that 0.0005 difference. So the answer is 0.84, and that's how we would use the table to find that. Oops, let's clear all of that. Okay. And that z-score is the corresponding percentile. So a z-score of 0.84 separates the bottom 80% from the top 20% when you're talking about those bone density test scores. People who have a bone density of less than or of 0.84 have a bone density that is higher than 80% of the population and lower than 20% of the population. Now we can also use Excel to do this. Oops. So here's how we use Excel. We do the same thing. We start by drawing our graph. And then I use that norm S INV function. That S is for standard normal. So this is a standard normal inverse function. And all you type in those parentheses is the area to the left. So the area to the left comes from doing NORM, norm S for standard normal, inverse INV. Select that, and then it says in the parentheses here, probability. So we want the probability to the left. And we get a z-score of 0.8416. Now this is doing backwards what we did with the other function. Remember when we were trying to find not the z-score, but the area to the left? We could use this function to do that. Remember that was equals NORM dot DIST for normal distribution. Let's say I want the area to the left of this number, 0.8416. If my mean is 0 and my standard deviation is 1, and yes, I want the cumulative area, so I type true, then if I've done everything correctly, this should give me that 80%. So this function gives us area close to 80%. And then this normal, this NORMS INV gives us the inverse of that. So this gives me the z-score that corresponds to an area, And then that norm.ds or dist gives me the area that corresponds to a z-score. And the area that they're giving you here is always an area to the left. And then when you use this, the probability in the parentheses always has to be that probability to the left, which is the same as the area to the left. Actually, if I see a typo, let's fix that. Okay, now we're doing something very similar whenever we're asked to find critical values for a standard normal distribution. A critical value is a z-score separating those z-scores that are significantly high and significantly low from the rest of the z-scores. Here's our notation. Z sub alpha denotes the z-score with area alpha to the right. I know this is sort of counterintuitive. Everything that we've talked about so far associates a z-score with an area to the left. All of the entries in that table A2 give us areas to the left. If we use Excel, they give us areas to the left. But now with critical values, we're looking at areas to the right. Since we've got areas to the left in our table and we're also getting areas to the left using Excel, we typically have to find 1 minus alpha, that area to the left, in order to find the critical z value. So let's say someone asks you to find z sub 0.025. So that they're just saying that alpha equals 0.025. The first thing that I would do is I would draw a picture. Just like this. And I want this area to be 0.025. And this area is going to be 1 minus 0.025. Which gives us 0.975. This z-score is defined to be that critical value, z sub 0.025. If I want that z-score, I want the z-score associated with an area to the left of 0.975. So if I want to find that z-score, I can do this one of two ways. And there are other ways as well if you use other technologies. But if I'm using my table, I just look at the body of the table this time, not the outside edge, but the body of the table, and I look for this area, and then I find the corresponding z-score. So let's do that. Obviously, that's a positive z-score if you've got 97.5% of the area to the left. And you're looking for 0.975 in the body of the table. It's a little bit hard to see, isn't it? It's so small. Oh, there's a 0.9726, 9738, 0.975 is right there. Oops. You see it? It's right there. So I want the z-score that corresponds to that area. Well, the beginning of the z-score is given by this 1.9. So it's 1.9. This is 1.90, 1.91, 1.92, 1.93, 1.94, 1.95, 1.96. So when z equals 1.96, the area to the left is 0.9750. 1.96. All right, so that's one way of doing it. Or we could just use this inverse function for 0.975. Now be careful whenever you're using this inverse function. Sometimes students will accidentally type in alpha. You don't want to type in alpha. You need to type in 1 minus alpha because this is looking for the area to the left, and alpha is always the area to the right whenever you're looking at a critical value. So find the area to the left, 0.975 in this case, and type equals norm SINV for, that's a standard normal distribution inverse function. And you get that. And if you round, you get 1.96. Now, if we use the other function that equals norm dot dist, and we type in z equals 1.96, and we're looking at a normal distribution with a mean of 0 and a standard deviation of 1. And yes, we want a cumulative distribution. So that means we want the area to the left. So we type true here. That should give us the area to the left of z equals 1.96, which we know to be 0.975. If we've done everything correctly, this should undo what we did up there. And it does. We get 0.975. And it's a little bit more than that. See how accurate it is? But if we are being as accurate as our table, we'll round to 4 decimal places and we get that 0.9750. So Excel gives you the same answers that you get in the table. Now, I wanted to point out that because of symmetry, if z sub alpha or z sub 0.025 is 1.96, that's separating that top 2.5% from that bottom 97.5% of the area under the curve. But because of symmetry, if z equals 1.96 separates the top 2.5% from the bottom 97.5, z equals negative 1.96 separates the bottom 2.5% from the top 97.5. So the area in the tails is always the same area if these z values have the same absolute value, but opposite signs. So the area to the left of a negative z-score is equal to the area to the right of a positive z-score, as long as they have the same absolute value. And that's all because of symmetry. Okay, so here's our summary for this video. If you're given an area bounded by an unknown z-score and you're just asked to find the z-score, you're going to use the methods of this section. Usually they're going to give you a picture and they're just going to say find z, and you'll just find z. But if you're asked for a percentile or a critical value, know that you're going to do exactly the same thing. They're implying an area. They give you a percentile. They say find the 25th percentile. They're saying find the z-score with 25% of the area to the left and 75% of the area to the right. Percentiles indicate areas, and they're actually asking you for the z-score that corresponds to that certain area. Now, if you're asked for, a critical value corresponding to a certain alpha, that alpha tells you the area to the right. Once you know the area to the right, you can find the area to the left, and then you're going to find a z-score using the methods that we talked about in this section. So whenever you see percentile or critical value, think that they are giving you an area or implying an area and asking for an unknown z-score. So whether they're giving you an area explicitly and asking for z, or giving you a percentile or asking for a critical value, in all of those cases, an area is implied and they're asking for a z-score. Now remember, all areas correspond to probabilities. So instead of saying, I want this area, they might be asking for a z-score that separates the top 30% from the bottom 70% or something like that. They might actually list them in terms of probabilities rather than referring to them as areas. Areas and probabilities are the same thing when you're talking about a standard normal distribution.